So this equation, we need to determine the member force in ED, BD, and BC. And then, first of all, we need to solve the reaction force. So reaction force at the support A is a pin support. We have two reaction force. So one is AX, one is AY. So then support C is a roller support. We have one reaction force, is CY. So now we can write down three equations of equilibrium. First of all, we can write down equation of equilibrium in x direction. Okay, so horizontal direction is equal to 0. If we say the red direction is positive, so we have AX is positive, and 6 kilonewton at the joint D is positive as well. So that's all the horizontal force, so is equal to 0. Then we have AX equal to negative 6 kilonewton. So that means the AX is go to left direction. Okay, so this is AX. Then we can solve AY or CY. So if we write down the equation of equilibrium of bending moment equation of equilibrium at support A equal to 0, and we assume the clockwise direction is positive. So look at the support A. We have 8 kilonewton have a bending moment, so it's clockwise, so it's positive 8 kilonewton times the lever arm is AB, so it's 2 meters. So this forced bending moment. The second one is CY. CY is go counterclockwise. The bending moment is counterclockwise, so it's negative CY, and times the lever arm is AC. AC is 4 meters. Okay. So now look at the 6 kilonewton, and the joint D is go to clockwise as well, so it's positive 6 kilonewton. The lever arm is CD. CD is 2 meters, so it's 2 meters equal to 0. And based on this equation, we can solve that CY equal to 7 kilonewton. Okay, so it's go up direction because we assume it's go up direction, and now CY is positive. That means our assumption is correct. So it's go up. After we have CY, then we can just write down the equation of equilibrium in y direction equal to 0. So if we see the positive direction is go up, and we have AY is positive, 8 kilonewton at the joint B is negative, and at support C we have CY is go up, CY equal to 0, and we know CY is 7 kilonewton. So we put 7 over here. Then we can solve AY is equal to 1 kilonewton and go up. So now we can write down here AY is equal to 1 kilonewton, AX is equal to negative 6 kilonewton, and CY, so CY is equal to 7 kilonewton. So after we have all these reaction force, now let's see how we can solve the member force in ED, BD, and BC. So first of all, look at the joint C. If we using methods of joint, so look at the joint C. We can draw the free body diagram. So this is joint C. And we know we have a reaction force CY is equal to 7 kilonewton. And we have a member force in CD, so assume this member force is in tension. There is a tensile member force. So tensile member force, that this member force FCD is go outwards to this joint. So it's FCD, and we know the member force of FBC. So FBC. So then we can write down the equation of equilibrium, Fx equal to 0. So for Fx equal to 0, we only have one force, is FBC equal to 0. That means the member force in BC is equal to 0. So we solve the one member force is FBC. And we can also know if we write down Fy equal to 0. So in y direction is equal to 0. the member force we have FCD. So positive is go up, so FCD is positive, and 7 kilonewton is go positive as well, equal to 0. Then we can solve that FCD equal to negative 7 kilonewton. Okay, that means the number FCD is in compression. Okay, so this is FCD. So after we load the FCD, then we can just using method of joint to look at the joint D. So if we look at the joint D, if we draw the joint over here, so this is joint D. Look at joint D, we have a member force FCD. So FCD is a compressive force. So compressive force then is go to the joint. So if the CD is a tensile force, that means the force is go outwards from the joint. But FCD we have solved is negative. Negative is a compression. So compressive force is go to the joint. So this is 7 kilonewton. Okay, and we have 6 kilonewton. We have 6 kilonewton go to horizontal 6 kilonewton. Go to left 6 kilonewton. So this is joint D. And we have a member force FED. So member force FED, if we see is in tension, so it's go outwards from the joint D. So it's FED. Okay, then we have a member force FBD. So FBD is in tension. So this is FBD. Okay, so when we look at the free body diagram of joint D, we have two unknown force, and FED and FBD. And for this joint, we can write down two equations of equilibrium. Okay, so look at the first of all, we need to know the angle of this one. So the angle for this BD and DC is 45 degree because this is the right angle, the right triangle. So CD is 2 meter, BC is 2 meter, and for this triangle, so it's 45 degree, 45 degree. Okay, after we know this angle is 45 degree, we can just put this angle over here, so it's 45 degree. Once we know the 45 degree, we can find the component FBD, so in horizontal direction and in vertical direction. So we have two components. So one component is FBD times the sine 45 degree. So this is for this one. And for the vertical direction, this is FBD times cosine 45 degree. Once we know the component of FBD, then we can write down the equation of equilibrium. So in horizontal direction, Fx equals 0, we see the right direction is positive. So for in horizontal direction we have FED. FED is go to left, so it's negative FED. And we have FBD times the sine 45 degree. And we know is go to left direction is negative as well. And we have 6 kilonewton is go to right direction is equal to 0. So this is first equation of equilibrium. So we have two unknown force, we cannot solve it. So we need one more equation. The other equation is Fy equal to 0. If we say it's positive, go up. So we have FBD times cosine 45 degrees. So it's this is force over here. So it's go to the downwards direction. Downwards direction is negative. And we have 7 kilonewton go up. So this 7 kilonewton is go up. So it's positive. And that's all. So that's all the force in vertical direction equal to 0. Then we can solve FBD is equal to 7 square root of 2, and it's equal to 929 kilonewton. Okay, So this is FBD. So this is FBD and it's positive. That means FBD is in tension. If we just plug in this FBD into this equation, we can solve FED. Easily solve FED is equal to -1 kilonewton. So that means the FED is compressive force. So it's in compression. So FED. So this is our force. We have FBD, FED, and we already solved the FCD. So we have determined the member force in ED, BD, and BC. So FED is -1 kilonewton. So member ED is in compression. FBD is 9.9 kilonewton. So it's positive. So member BD is in tension. And we have so FCD, we don't need to solve FCD, so we need to solve the FBC. So FBC is equal to 0. Okay, so 0 kilonewton. So we don't need FCD, so FBC. That's all. That's everything we need to solve FBC and FBD and FED. So for this question, we're using method of joint to solve the member force. Okay, that's all. Thank you.